Hey guys, so in today's video we'll learn some basic concepts about transducers and sensors. We'll learn about them as well as their classification and characteristics. So coming to sensors, they are basically instruments which senses variation in input quantity to produce variation in same or other form of quantity. The best example of a sensor is thermometer. It senses variation in temperature and it displays in temperature unit itself, right? So next we have transducer. These are instruments which sense variation in input physical quantity and provides usable output in electrical form using transduction principle. Basically, these are sensors that produce output in the form of electrical form. The best example is potentiometer. A potentiometer senses variation in displacement and produces output in the form of voltage. Now we'll move on to classification of transducers. Transducers are classified on based of many criteria. First we'll see principle of transduction. Based under this criteria we have resistive type, capacitive type and inductive type transducer. In resistive type transducer, measurement is converted in change in resistance. A good example is strain gauge. Similarly, in capacitive type, the measurement is converted in change in capacitance. A change in capacitance occurs either by changing the distance between the two plates or the area overlapping the two plates or by changing the dielectric. Now, inductive type, here the measurement is converted into change in self-inductance of a coil. It is achieved by displacing the core of the coil that is attached to a mechanical sensing element. An example is LVDT. Now, seeing whether they are primary or secondary type. So, primary transducers are those which converts physical quantity into mechanical output. A burden tube in LVDT is an example of primary transducer. A secondary transducer is a transducer that converts mechanical quantity into electrical output. Windings in LVDT is an example. So then comes a transducer or inverse transducer type. Transducer is basically non-electric quantity into electrical quantity, right? Inverse transducer is exactly the opposite. It converts electrical quantity into non-electrical quantity. The best example is piezoelectric crystal. It is both transducer as well as inverse transducer type. Now, based on whether it is digital or analog, a transducer that converts physical input into analog output is basically analog transducer. An example can be LVDT, thermocouple and so on. Digital transducer shows us digital output. Strain gauge is basically a good example of digital transducer. Then whether a transducer is active or passive. Transducers that do not need any electrical source of power for operation are called active transducer. They are self-generating devices which operate under energy conversion principle. A thermocouple is an example, whereas passive transducer do not need any external do need external source of power for their operation. They are not self-generating type, and a DC power supply or an audio frequency generator is used as external source. A thermistor is an example of passive transducer. So I hope we are clear with the classification of transducers. Moving on to characteristics of transducer. There are basically two types of characteristics, static as well as dynamic. Static, as the name suggests, these are the characteristics that do not vary with time. First, we have accuracy. It is the closeness of obtained reading to actual standard reading of a variable being measured. It is often specified by error or inaccuracy. The formula to error is shown on the screen. Then comes precision. It is the repeatability of measured value of a variable being measured. Then comes resolution. It is defined as the smallest incremental change in input that would cause a detectable change in output. It is often expressed as percentage of measured range. Then comes threshold. It is smallest input change that produces detectable output. Sensitivity is the ratio of incremental output to incremental input. Selectivity is measurement of performance of an instrument. That is how an instrument responds to only certain range of signal and rejects the others. Then comes linearity. It is basically the linear relationship between the output and input. Then hysteresis. It is the difference in output y for a given input x when the input value reaches y in upscale as well as downward direction. Stability is the ability of an instrument to retain its performance throughout its specified lifetime. Range is the minimum and maximum value for which an instrument is designed to measure. That is all about the static characteristics. Then moving on to dynamic characteristics, there are 4. These are characteristics that change with time, right? So speed of response is defined as the rapidity with which a measuring system responds to change in measured quantity. Measuring lag is the retardation or delay in response. Fidelity is defined as the degree to which measurement system indicates change in measurement without dynamic error. Whereas dynamic error is the difference between true value of the quantity changing with time and the value indicated by the measurement system if no static error is assumed. So that's all for today. If you like, please subscribe and drop a comment if there's any doubt about the content. Thank you and have a great day.